Hello, friends. So what I want to share with you today is a little bit of Java programming. Today we're going to be working out of Chapter 9 of Daniel Liang's Introduction to Java Programming. And what we're going to be working on is the stopwatch problem. This is question number, or exercise number 6 out of the back end of that chapter on objects and classes. So let's get down to the problem right quick. So what question number 6 asks us to do is it says create a class, design a class named stopwatch, and it should contain the following items, basically what you need to make a stopwatch work. And then after that, you're supposed to draw the UML diagram and then write a test program that measures the execution time of sorting 100,000 numbers using a selection sort. Okay, well, I'm gonna have some fun with this. We're gonna modify it just a little bit. I'm going to be leaning on one of the people that I like to follow sometimes, and on GitHub, J221 out of New York has posted a lot of these solutions, and so we're in their GitHub repository, and this is exercise chapter 9, and they've got solutions for 9.6. So we're going to have the exercise 9.6 main class. And then we're going to have the stopwatch class that they're working out of. And we're going to be referencing this just to make sure that we keep everything moving along, because there's a few other things that I want to do that aren't covered in this solution, but this solution is a great place to get started and help us get started quickly. Okay, so with that, let's pop in here to Eclipse. What I need to do is I need to first make a new folder, or a new project folder, or a package, and we'll call this chapter 6, chapter 9, exercise 6. And we'll go ahead and click finish on that, and then we'll make a new class inside of it. And for this one, we will call it chapter 9, exercise 06, and this one we will include the public static void main. Okay, so two things that I always like to do: make sure that it starts, and make sure that it finishes. Okay, so we've got that, it started, it's pretty. Not going to worry about copying over the problem description. Since it's got it online, I'll just take advantage and drop that right in here to our folder. A little bit different format than what I usually do. Whenever I borrow somebody's code off of the internet, I usually like to go in and also kind of acknowledge and that way people realize, oh, hey, you know what? There's more information out there on the internet that we can go get and it might be useful. So we've got the project description. What we're going to do is we're going to start building this thing. So they actually have a UML diagram in the other one, but just following along from the example, we'll make sure we get the example up and running first. Control A, Control I, save it. Now it says, hey, this doesn't exist, so we'll go ahead and create it. And our integrated development environment does everything for us. So it knows that it needs to be public, it knows the right package, it gives it the right name, and it knows not to make it a main one. And so we can just click finish, and it just nails that for us. Now, one of the things that I always like to do is I like to make a default constructor right off the bat, where I don't pass it anything, and it's just an empty set of brackets. Okay, so that handles that first line of code. Let's see what they've got next. Okay, so they're focusing primarily on the problem at hand. So let's go ahead and follow along with what they're doing. Control A, Control I, save it. I like to do this slightly differently. Let's look how he's doing it in the code. Yeah, he's taking the, he's using this to first create the array, and then he's going to use that array several times down here. So I'm gonna modify this just a little bit. I'm gonna go ahead and create this thing first. So let's call it original array. The reason I want to do that is I'm going to call this, and then I'll call this fill original array. And what I'm going to do is I'm going to pass our original array into that. Now, this doesn't exist yet, so we'll go ahead and create it. And so this way, we don't have to return anything. And so it's a void. And now we can just, we can pop down here and borrow this. And so we can say, we changed our names just a little bit. Okay, so what this code does is it says, hey, let's create an original array that'll hold 100,000 numbers. We're going to trim that down just a little bit to like 10 numbers. 10 numbers is a good start. And that's a bit large. Let's make it random numbers. Actually, we've got a handy dandy thing that we were just learning about. And so I think I can import that. Yep, cool. And so instead, let's do next int, and let's just pop this off here. Okay, and let's make this have a seed of 1,000. Okay, cool. Now, print array. And let's create the method print array. Not using my to-do statements today, so I'm just going to continue to have some fun with this one. Actually, we'll do it one way that I know that makes sense to me. We can just grab this. And then down here, we can just say, okay, so we're basically going to use a for loop, and let's refactor that right quick. Refactor, rename, and let's just call that index. Okay, so for our index, starting off at the first address of our array, and then going over the entire length of our array, let's print off every number. Now, pop that off. This little concatenation here is going to also include a little space. And then when we get done with our for loop, what we're going to want to do, we're going to want to go ahead and go to the next line. So we see our sequence 87, 35, 76. And you know what? That's good. That's good because I don't see any repeats. Relatively small set of numbers. We'll be able to see that our sort is working and all that kind of stuff like that. So now we can come in here and we can say original array, and now I can say copy one. And now I can come down here and we can do, we can say copy array, and we will say now we can just create this little thing. And now we can use it and we can come down here, grab this for loop again, and then we can make home I equals original array. Now, again, I need to just fix this, refactor, rename, and we're also going to call this one index. Let's call it copy index. And so I'm going to refactor this one, and let's call it index. And the reason why I'm doing this, if you do a control F for the letter I, you're going to find like a bunch of letter I's. If you do a control F for fill index, you're going to find exactly 1, 2, 3, 4 of them. If you do control F for the letter I, you're going to find a truckload of them. So anyway, now I've got that, and now we can come in here and we can try this. Cool, and we can see that copy one is a perfect copy of the original array. I'm going to have some fun with this later on. What I didn't tell you is I'm a pretty significant high-performance computing groupie or supercomputing groupie. My heroes are folks like Bob Panoff, Henry Neiman, Jack Dungara, other guys like Kevin Thompson up at the National Science Foundation. There's a whole lot of money and fun and friends and great, just very, very kind people, and they let you borrow their multi-million-dollar machines. And so I have a lot of fun asking the question, exactly how fast can you get something done? How hard can you push your machine? So anyway, we've got this. Now we can fill up our array. Let's pop back to the problem at hand. In the problem at hand, we're also building a class for a stopwatch. And we've got a few more things that the stopwatch needs to do. And so for that, I'm going to go back to the GitHub page of the other guy. So now it says invoke the start class, and then yeah, let's just get this going. So I'll just grab all three of these lines right quick. All three of those little blocks of code. And we've got our little stuff here. So we can just pop this in. Now, Control A, Control I, and it says, hey, start does not exist. So let's go ahead and create the start method. For this, we'll pop back over here. We've got a couple of private data things in here. So let's go ahead and grab those, get those pasted in. These are going to be private, and long as something that works well with the time, and this is where we're going to keep track of our start time and our end time. That's good. We also got a little note here. In his default constructor, he's got it saying, hey, you know what? Go ahead and grab the system time as soon as you're made. And that makes sense. All right, what else do we have? Ooh. And so we've got start, paste this, got that. And ooh, well, let's pop back here to our next problem. And instead of random array, let's do copy one. And then let's take care of this one first, create the stop And so let's go back. He's also got a stop. We'll just borrow this right quick. And we will paste that right here. Okay, now we've still got some problems. This whole selection sort, it doesn't exist yet. So we'll go ahead and create this. Selection sort, he actually has that defined in his code. His selection sort, he's passing it an array. We're calling ours copy1. So we will just pop down here. And we'll just call this array. And so now we pass in an array, and then it says, hey, you know, find out what the, you start out, let's go, let's just refactor this right quick. Rename, let's call this the sort index. Thank you. All right, so let's go through a for loop, and our sort index equals 0, and we're going to sort the entire array, and just every time we're going to move on to the next one. All right, so our minimum starts out with whatever we are currently at, and then our minimum index equals sort index, our minimum is whatever our sort index is, which is controlled by our for loop. And then the minimum value is wherever we started. And then it says, okay, do another for loop inside that. And this one we're going to call, all right, let's rename this right quick. We'll call this sort inner index. Okay, so our sort inner index, and says, let's wrap this just a little bit so we don't miss anything off the far end. It says, hey, you know what? Whatever our sort index is, start off the one right after that, like the next number. And what I want you to do is, while the sort index is still, we haven't reached the, while it's less than the last address, just keep going until you get to the end, one at a time. If our array of our sort inner index, so if our current value of our array is less than this other minimum out here, then first of all, update that, and then update the minimum index. Otherwise, just keep going. And then it says, if sort index is not the same. So if we go through and we actually make a change here on any of this, then it says, all right, we're going to do a little swaparoo. And so it says array index and minimum index now gets this value, gets this value, and there we go. So we're basically using this as kind of like a temporary storage location to help us do the swap there. And so we just keep going and going and going and going. And this is always going to take the minimum value and slam it down to the front. And so, cool. All right. Save that puppy. Run that puppy. Okay, need more input, as they say. All right, so after we stop the stopwatch, then let's do this. First question, sorted copy 1. The question is, did it actually sort it? So selection sort, sorted a copy 1, selection sort. Okay, that would definitely be, that would give me some reservations, right? All right, so I'm not convinced that the selection sort worked, but I'm okay with that. All right, where did I screw this one up at, right? So let's just start digging in. We've only got 10 numbers. So min plus min k. All right. Now I can do Cool. So we are able to successfully see that the loop is going through. And now let's see here. We can also print off this out. Let's do sort inner index. And we can do and yeah, it's blowing through all of that, and the list is getting shorter, and we've got a little bit too much information now. I'm going to say that's not a good comment to have. I'm not going to delete it. I'm just going to comment it out right now, and then here's where things are going to get interesting. Okay. All right, so let's slow down. Let's take a look and see if we can make sense of this. All right, minimum index is 0. So that's, yeah, our minimum is 87. And so, bam, right there, we should have went ahead and said, okay, this is a new minimum. But the minimum, 35, I see. So this is when we hit 35, and this is when we hit 24. All right, but the problem is, let's see, the problem is we need right here to print off sort index. And you know what, we've already got that. Thought we had that. No, sort index. Okay, now let's take a look. It says, all right, 87, yeah, our minimum index. This is our minimum. Our minimum index is, it's the first number, which Java is weird, and it starts counting arrays at 0. This is when it hits 35. This is when it hits 24. So, array of minimum index. So it should be swapping. It should be swapping them right there. And so what we should be able to do right after that, you know what, I should be able to do it right here. And this is, can I get away with that? Is it gonna work? Okay, so that's weird. Okay. So starting at the top, okay, 87.35. So after this one, we switch it. Now 24 is our new minimum, and then 35, that's all good. And then 35, and then 41, that's good. 45, that's good. 49, good, 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 good. 50, yep, and then 64, 76, 80, got it. The problem is, so sorted copy 1, so fill the original, copy the array, copy 1, start the stopwatch, selection sort copy 1. That would be why, my friends. That would be why. Yep. So a lot of print statements, a lot of debugging just to find out. I got in a rush when I was copying the print statement, and I needed to slow down a little bit. So now we can see here's our original, there's our copy. You know what? This is why some days we have slow programming days. I've got a few print statements here that I want to go get rid of now. All right, save that, run it. Hey, you know what? There we go. 24, now we've got it sorted. Now that's doing great. Cool. Okay, so now we've got that working, and we can confirm that it runs correctly. Now let's go back and let's see, I think we've got a little more work to do here. And it says display the execution time. So let's go ahead and grab that. Oh, we need get elapsed time. We haven't created that yet. So we'll go ahead and create that. We'll bop back over here. I'm sure that's baked in. Yep, right there. Right like that. And so get rid of this one. And it probably is going to say create method get end time. This one's probably going to say create get start time. And so these are going to need to change just a little bit. And we'll change this to, you know what, let's take a look. See if he's got these. Yep, they're both doing longs. And so this should be a long as well. Long here. Long here. Along here. Let's do this dot start time. Let's do this dot end time. And that's pretty happy. Cool. That's pretty happy. Cool. 0 milliseconds. Well, we're not actually doing 100,000 numbers. We're only doing about 10 numbers. All right, so we're going to pop off just a little bit here. We're not going to print the arrays anymore because we're going to start playing with this just a little bit, and it's going to get big real fast. So 100,000 numbers. Let's pop this. Let's do this. Let's do int size equals 10, not 10J. Okay, 0. Let's just see how big this needs to be before it registers anything. So 1,000 numbers, it registers as 4 milliseconds. Okay. So the execution time of sorting, okay, cool. All right, now, this is why I wanted to get crazy. I'm gonna get rid of this as well. And then, oops, swing and a miss. And nope, don't need that. Okay, now how is it printing? Cool. Now, let's go have a little bit more fun. Let's come up here and let's make this copy 2 and copy the array. And we'll say copy 2. Still runs, not a problem. And then now we can do built-in sort. And this time, let's just slow this down. Let's just tighten this up just a little bit. There we go. And so, oh, we gotta do this print statement here, because we're going to be reusing these variables, start and stop. Okay, so instead, let's do, I think it's arrays.sort. No, not parallel sort. I want just arrays dot. There we go. Control Z. And then we'll call this copy 2. All right, let's just see if that goes. You know what we need to do? We need to copy this little thing right here, right? Execution using okay, so a little bit shorter, little bit slower, in fact. Let's see if it registers with 100. Yeah, both 0 on that one, so that's not interesting. Okay, that time, but I guess what the point I would like to make is you're not seeing anything very consistent here. So that's, well, let's just run it 3 times. So 15 to 1, 10 to 0, 5 to 2, 17 to 1. Okay, when you start it running long enough times, then the first one's a little bit slower, the second one is a little bit faster. And so, okay, now we can come in here and we can do this again. Copy 3 does not exist yet, so let's go create copy 3. And then we can come down here and we can say, get rid of this line. And then the default that it was trying to pop over was this little one column. Only one R, I believe. There we go. And so let's do I wonder if it's got a capital S. Okay. All right, let's see, let's just run that several times, see if that's consistent. 5, 1, and 0, 4, 1, and 0, 12, 1, and 0. Okay, let's see how this scales. So let's go ahead and make this one bigger. Yeah, go ahead and save those. We'll let that be the default behavior. So 35, 7, and 16. So consistently, the built-in sort is the fastest one. Now let's add another 0 to our problem. So now we're up to 100,000. And now it's taking a little bit longer, blowing a little more smoke. So 298, 15, and 7. 220, 22, 91, 13, and 8. 15 and 9. Let's throw another 0 on there and see if we can make this even a little more interesting. So this is why I always like to say, kind of play with these things and look at what algorithm works the best. Sometimes having the right algorithm really will make a significant difference. There are lots of other things that can be going on right now. one of the questions that I would have is, hey man, why are some of those big numbers getting so random? Why are they changing so much? Well, now the array is taking long enough to sort. Your algorithm, your operating system might say, you know what? I can't give you 4 cores right now. I can only give you 1 core right now. Or in my case, I've only got 2 cores to begin with. And so it might be like, hey, did you know that like the user moved the mouse? And so I have to switch priorities. So sometimes your operating system can have some reason like a security feature or something like that that'll slow your sorting down. The other thing that we're doing inside the selection sort, it maybe is not, the selection sort maybe is not the most efficient. I think the built-in sorting mechanism is a variety of a merge sort. And so I think the merge sort algorithm might just be literally more efficient. And so it's got nothing to do with the code. It's just got everything to do with, okay, what's going on there? The code might be perfect. The algorithm just may not be as efficient. And so that's the magic smoke coming out of my processor right now. It's working as hard as it can. It's doing the best that it can, and its best just not very good. And so it's grinding away on this. It's having a fine time, and still not done yet. So I'm gonna throttle this back. We're gonna take that 10. We're gonna make it into a 5. So half as much to do. I'm gonna go ahead and terminate that last one. Let's try to run it with half as many numbers, see if it'll get done. But no, for the most part, you know what? It's still taking too long. So let's just save that. I'll stop the termination. Let's run it where it'll at least finish. Let's finish on one that gets completed. So there you have it, folks. The parallel sort is starting to shine just a little bit. The built-in sort, not as much. But I would like to point out for smaller arrays, the built-in sequential sort was actually faster. If we just pop that sort out of there, it'll start running a lot faster. And you can see as we start to get to bigger and bigger numbers, the sequential sort is going to continue to grow, but the parallel sort's not going to go quite as much. Throw in another 0, and now they take a lot longer, but they at least get done. And we can even throw in another 0. Probably won't blow too much magic. Actually, no, this is me just having fun. So with that, friends, I think let's go ahead and call that quits. I'll get this all pushed up again. Kudos to my friend that posted this out there. The Jabari James, I think is how that's pronounced. Anyway, J squared 21. Appreciate this site because I do lean on it when I just want to get something up and get it running. Anyway, thank you all for your time. Have a wonderful day.